In the next set of videos, we're looking at few names that are associated with the graph. The graphical meaning of this is the basic agenda actually. And out of this graphical meaning, we're going to derive the mathematical as well. And end of it, we will look into the information that it can give. So this is the agenda for the next set of videos. The first terminology is turning point. So point on the graph of a function where the function changes direction. That is in terms of slope, point where there is change in sign of the slope. For this to happen, slope at the turning point has to be 0. So let's understand this. I have the required graph over here. Okay, it's the same graph as what we have written over there or pasted over here. So please observe the slope of this graph. So what's happening? It's positive. So as in when I move across, it's still positive, and here it becomes 0. And then it is negative, right? And as in when I move across, here it's 0 and it becomes positive. So what we saw here was it's positive over here, negative, and again positive. Somewhere along the line, we have a point wherein the slopes are 0, right? These 2 points are known as turning point. Turning point. Okay, so in terms of slope, at the turning point, the slope of any tangent will be 0. I hope it made sense. Now, on this we can build 2 more terminologies known as concave up and concave down. Concave up, the shape, it is the name given to the shape. So if we have something like this is concave down, right? It's basically inverted U. So inverted U is known as concave down and this is known as concave up. So here graphically what we will see is the tangent at the turning point, it lies below the graph. This is concave up. So this is a U in this manner. The tangent is below the graph, as you can see. The tangent is below the graph. For concave down, the tangent at the turning point is above the graph, right? So this is below the graph and that's above the graph, and this is an example of concave up, and this is an example of concave down. Agree? Right? Makes sense? Now, there is one more variation to all of this. That's your point of inflection. It is spelled in this manner and this manner as well. I don't know the reason why is it so. So I have a graph over here. What is the slope over here? It's negative. Till now, wherever we saw a graph which has a slope of 0, the slope would have flipped from negative to positive, right? As per the above discussion, it should have flipped from negative to positive, but here again it's negative. Before 0 it was negative, and after 0 it was negative. It is negative again. You have seen such cases, to be honest. Think about it. You have seen such cases. Such point wherein, right, the slope becomes 0, but the concavity of the graph flips. It is basically half U and half inverted U. It's a combination of that. So such point is your point of inflection. So this here is a slope of 0, but the graph here for this graph actually it's positive, and here too it is positive. Right, the slopes are positive. Let me show that. So that graph which we saw with negative, that was negative x cube. Now we're looking at positive x cube. So you can see over here the graph is positive then we have a 0 over here somewhere over there, and after that it is positive again, right? The continuation is not there. It's not a complete U or inverted U. So such points are called as point of inflection. Now, point of inflection are not the same as your turning point, but there is a common terminology known as critical point. Critical point includes turning point and your point of inflection. Okay, so this you guys have to keep in mind. Yeah, so this is your basic aim of the set of videos that we're going to see. And also in time, we're going to derive critical information that we'll need for a given question. And yes, you guys have to draw the graphs and try out the graph in our Python IDE as well.